Hey everybody. I wanted to finish up with a little video about the kFold cross-validation. I like kFold cross-validation because it gives you, so in the two-thirds split, two-third, one-third split, you really only get one estimate on your parameter. So, sorry, not parameter, on your statistic, on your test statistic. So I was looking at the R squared value of the linear model, right? That's the thing we've talked about. In the last video, I was like, yeah, 0.88, it's kind of close to 0.83. That's like all I could really say, right? Um, so one of the things that's really nice about kFold is that you actually repeat that process multiple times. So you go ahead and you do the cross-validation multiple times. In kFold, what you do is you go ahead and you chop your data up into into K pieces, and you hold back one of the pieces and fit your model on the remaining pieces, and then test the model on that piece that you held back. Then mix them all together, hold back a different one this time, and repeat K times. So you can run a statistic on the statistic, on the test statistic, kind of a meta statistic, right? So let me show you how you do that here. You do have to run this idea of a train control. So I'm running a method of cross-validation, and I'm running it 10 times. I'm going to do the model. I'm going to train the model. I'm doing wins as a points as a predictor of wins. Data equals data. Method equals linear model. And then TR control equals train.control. That was this thing that we set up here. So I'm going to do a 10-fold cross-validation. I'd almost suggest you guys use this code. The only things that change would be maybe this. You're supposed to do a linear model, so probably leave everything else the same. So if I run this, I've also asked it to print model. So I've done no pre-processing. I had 31 samples. I was getting one predictor. That's the R squared value. So if we look at this, we see that we did the cross-validation on the 10-fold. We had 27, 28, 27, 29, 27. These are the different sample sizes that it ran on. And the intercept was held true. So those are my things. And my R squared is always the thing of interest to me. I can also run a summary on the model. And the summary is nice because it'll give me these estimates based on this kFold cross-validation. So that's kind of cool, kind of a cool way to do it. Again, we see about a half a point per win. Yeah, you get 2 wins for 2 points for a win. We see this intercept. It's been pretty consistent. We actually don't see the intercept being statistically significant. Of course, that still makes sense, right? So there you guys go. This process is pretty straightforward once you do this, but describing it is the tricky thing, right? So you're gonna slice your data up. You're gonna slice your data up. You're gonna pull one piece of the pie out. You're gonna mix up the rest, and then test on that one piece of pie. Then you're gonna stop. You're gonna pull another piece of pie out, train, test on that piece of pie, put it back in, pull a different one out. Repeat that K times. That's the kFold. All right, so hopefully that makes sense. Again, here mostly this is coding, doing this. I should say that the cross-validation doesn't make a ton of sense in the linear model. Neither does the bootstrapping. But where the cross-validation really comes into play is some more crazier ideas, especially when we try to do predictions. So if we wanted to predict whether you lived or died on the Titanic, cross-validation becomes really important. There isn't this idea of an R squared to estimate. Instead, you're actually like, did I get it right or did I get it wrong? What proportion did I get right? Then that becomes really important. Okay, so keep working hard, guys. This is going to conclude these sections of videos.